In this video, we're going to go over how to do your time value of money project, both with Excel and with the included interest charts. The first tab you have to look at is the future value of $1. You're going to deposit $5,000 at 8% over 10 years. The compounding is annual. Because this is a future value of $1 problem, using Excel, we're going to use the future value function. So I'm going to go into Formulas, Financial, and FV. So if you remember, in the rate goes our I. In this case, because the compounding is annual, our I is 8% divided by 1. You can leave out the divided by 1 because anything divided by 1 is itself. N per is going to be 10 years. And remember, this is an amount deposited. When you deposit money, you spend money. PMT box would mean that we're depositing $5,000 each year of the 10 years. This is the future value of $1. We're making one single deposit. So in the PV, I'm going to type a negative sign, and I'm going to click on the 5,000. And the answer is that my money more than doubles. The future value is $10,794.62. Well, what's the difference between the principal and the maturity value is the interest. So the interest earned is just the difference between the future value and the amount deposited. Now, if you wanted to solve this using using the interest charts, we have to calculate our I. Our I, in this case, is 8% divided by 1, which is 8%. Our N, 10 years, multiplied by 1 compounding per year, which is 10. So we're going to go to our FV of $1 chart. And we're going to look for the factor that's at the intersection of the 8% column and the 10-period row. So I'm going to go to my future value of $1 chart. I'll scroll in a little bit. So once again, we need to look at 8% and 10. So I'm going to go to 8%. I highlighted it, so 10 is going to be the second. So we have a factor of 2.15892. So another way that we could solve this is to just take the amount deposited and multiply it by the factor from the chart, 2.15892. And notice we're only 2 cents off, so we get a very, very similar answer. Excel is exact. Using the interest charts, it's just an estimate. And then we calculate our interest earned exactly the same way. All we'd have to do is take the future value and subtract out the amount deposited, and that's our interest if we use the interest charts. The next one we're going to have to work on is the future value of an annuity. So in this case, instead of making a single deposit, we're going to make a quarterly deposit of $3,000. Our annual rate is 8%. Number of years is 5. Compounding is quarterly, and this is going to be an ordinary annuity because payments are at the end of the quarter. So if we want to use Excel, I'm going to click in cell B9, Formulas, Financial, and FV. So in this case, my rate is 8%, but I have to divide by 4 because there are quarterly payments. So I have to use an I of 2%. My N per is the 5 years multiplied by 4 payments per year, so my N per is 20. And this time the 3,000 goes in the PMT box because PMT models that you're making a payment every single compounding period. So PMT models that we're making 20 payments of $3,000, which is exactly what we're doing. So in PMT negative, click on the 3,000, and if this were an annuity due instead of an ordinary annuity, if the payments were at the beginning of the quarter, all we'd have to do is put a number 1 in the type. So we click OK, and we see our answer is $72,892.11. Now to calculate the interest, we take the maturity value and we subtract out what we deposited. So our maturity value is the $72,000, and what we deposited was 20 payments of $3,000. So we subtract the $3,000 payment multiplied by the number of years multiplied by 4 payments per year. So the maturity value minus what we deposit, and we come down to $12,892.11 in interest. Now, once again, if we wanted to use the interest charts to solve the problem, we'd have to calculate our I. In this case, our I is 8%, but we have to divide by 4 because of the quarterly. So we're going to use an I of 2%. Our N, 5 years, multiplied by 4 payments per year, gives us 20. So we're going to use an I of 2% and an N of 20. So we're going to go to the future value of an annuity chart and look for the factor at the intersection of the 2% column and the 20 period row. So I'm going to go to my future value of an annuity chart, 2% column, 20 period row. My factor is 24.29737. 2% column, 20 period row. So that factor is 24.29737. So I'm going to go back to my future value of an annuity tab. And if I want to use the interest charts rather than Excel, I would just take the amount of the quarterly deposit and multiply it by my factor from the chart, 24.29737. And notice how I actually at this point get exactly the same answer. In fact, I'll write it down here. Factor from the chart, 24.29737. So then we would calculate the interest exactly the same way. So to calculate the interest, the first thing I would do is take the maturity value, the future value, and then subtract out what I deposited. Well, I deposited 20 payments of $3,000, so I deposited $60,000. But to calculate it using Excel, I'm going to take the $3,000, multiply it by 5 years, and then multiply it by 4 because it's a quarterly payment. And notice we get exactly the same answer, $12,892.11 in interest. Now, let's move on to our third problem, present value of $1. So with the present value of $1, we have a maturity value of $100,000. It's an annual rate, 15 years, and we just want our present value. And in this case, it's imputed interest. Because we know the maturity value, we have to use the rate and number of years to figure out how much the interest is. So using Excel to calculate the present value, I'm going to go to Formulas, Financial, and this time I'm going to go to PV. Since this is annual, there's annual rate and number of years. There's no mention of compounding. We'll use a rate of 9%. We'll use an NPER of 15 years, and because this is present value of $1, the $100,000 goes in the future value. If you put it in the PMT, you're modeling that we're going to be paying or getting $100,000 each year of the 15 years. We actually get the $100,000 or pay the $100,000 at the end of 15 years. So we're going to skip over to future value, negative $100,000. Present value of $100,000 over 15 years is $27,453.80. So working the problem backwards, if I deposited $27,453.80 today, if I kept it in an account for 15 years that earned 9% annual rate of interest, at the end of the 15 years, I will have exactly $100,000. So my imputed interest is my maturity value minus my present value. If I deposit $27,000 and get back $100,000, my interest is going to be about $73,000. So $72,546.20. If we're going to solve this problem using the interest charts, once again, we need to calculate our I. In this case, our I is just going to be 9% divided by 1, because there's no mention of compounding. The only one we can assume is annual. Our N is 15 years. And this time we're going to use the present value of $1 chart. So I'm going to go to my present value of $1 chart, 9% column, 15 period row. It looks like the factor is 0.27454. So I'm going to click back on my present value of $1 tab, my factor. It doesn't look much like factor. My factor from the chart is 0.27454. So once again, if I was going to use the interest charts instead of Excel, all I would do is take the $100,000 and multiply it by the factor from the chart, 0.27454, and I would get $27,454, so very close. And once again, I would just take the maturity value and subtract the present value to calculate that imputed interest. We are now down to our last problem, which is the present value of an annuity. So with the present value of an annuity, this is kind of like if you know what kind of car payment you can afford, how expensive a car are you buying? So in this problem, we're making payments of $3,000 semi-annually for 5 years at an annual rate of 6%. We want to know how much that's worth today. So I'm going to click in cell B8, Formulas, Financial, and PV. Since this one is semi-annual, for the rate, I want to take the annual rate and divide by 2, because semi-annual means 2 times a year. In my N per, I'm going to take the number of years and multiply it by 2. If you do something 2 times a year over 5 years, you're going to do it 10 times total. Now this is an annuity, so the payment is every 6 months. So in the PMT box, negative, and then click on the 3,000. We click OK. Our present value is $25,590.61. So if you could make these payments, $3,000, semi-annual over 5 years, the amount of car that you could afford today, $25,590.61. Now notice, if you're making 2 payments a year of $3,000, you're making a payment of $6,000 a year over 5 years. So the total interest paid is going to be what you're paying back minus what you borrowed. So $3,000 over 5 years times 2 times a year is what we're paying back. $25,000 is what we're borrowing. We are paying interest of $4,409.39 over the 5 years. Now for the last time, if we want to solve this problem using the interest charts, In this case, our I is 6%. Oops. Where's my eraser? Undo, undo. My I is 6% divided by 2, which is 3%. My N is 5 times 2, which is, of course, 10. And I'm going to look at the PV annuity chart. So I'm going to go to my PV of an annuity chart. I'm going to go to my 3% column. And I'm going to go to the 10-period row. So 3% column, 10-period row. My factor is 8.53020. So I'm going to circle it here so you can see where it is. 3% column, 10-period row, that intersection. Now I'm going to go back to my present value of an annuity tab. If I want to solve this using Excel, I wanted to write down my factor. So my factor from the chart, 8.53020. So solving this using the interest chart, I would just take my payment, 3,000, multiply it by my factor of 8.53020, and I have 25590.6, so I'm only off by 1 penny. So now once again, to calculate the total interest paid, I am paying back $3,000 over 5 years, multiplied by 2 times per year. So I'm making 10 payments of $3,000, $30,000 is what I'm paying back, and I'm borrowing 25590.6, so my interest 4409.4. Once you're done with this, just save and upload it to the assignment link.